Hi guys, welcome back to my channel. In today's video, we're gonna be continuing our discussions on the functions. So last time we did look at the quadratic functions, which are the most, asked questions in exam. So the second most asked questions is on the hyperbolic functions, right? So yeah, in this video, we'll cover all the important aspects that you need to know for hyperbolas. And, by the end of it, you should feel confident to answer all the questions on the hyperbola and, be able to plot the graph and, just do well in those exam questions. Okay, so yeah, without wasting time, let's get to the topic of this video. So I'm just going to share my whiteboard. Okay, so as we've mentioned in the past video, so the technique or the trick for you to do well in these function questions, you need to be able to understand the certain characteristics of each function and be able to use those characteristics to derive to answer the questions and also be able to plot the graphs under various scenarios, right? And also when you're given a scenario, you need to be able to determine what information you can use to answer the questions. Okay, so yeah, essentially the most important things that you're going to focus on, firstly is to understand the form of what? The form of the function. Remember, in a quadratic, we mentioned there's a standard form. So essentially, this is a standard form that I'm talking about. What is the standard form, for a hyperbolic function? You need to understand impact of each parameter function, right? And then you need to be able to derive what? The lines of asymptote, the line of asymptotes. So if you don't know what asymptote is, so asymptote essentially is the line that the curve can never touch, because at that line, the curve will be undefined, right? So essentially it's the set of y or x values that cannot cannot be input into the graph, because you're gonna get error in your calculation, right? So as you will see in this example, we have two lines of asymptotes when it comes to a hyperbolic functions. And then, yeah, you need to also be able to plot them, not just know how to derive them, but also to plot them. And then the other thing is obviously domains and ranges. And then you need to derive equations of line of asymmetry. And then the other stuff is just what you've already covered, as I mentioned, that intercepts. So intercepts applies to every function question. The principle is the same. When you get x-intercept, remember x-intercept is where the graph cut x-axis. So at that point, the y values are 0. That's why you always let f of x equals to 0 when you're solving for x-intercept. And then, yeah, when you find the y-intercept, remember y-intercept where the graph cut y-axis. And at that point, x value is 0. So you set x2 equals to 0 and find the y-intercept. Right? So the principle is the same, whether being linear functions, quadratic, hyperbola, exponential, it's the same thing. You don't have to stress much. Right? Yeah, so essentially this will be the main focus for this video. And yeah, this is all you need to know. It's all you need to know to answer all the questions in the exam, right? Confidently so. Okay, so yeah, without wasting time, let's get to it, right? So yeah, when we talk about the hyperbolic functions, we're talking about the functions of the form, the functions of the form y equals to a is a parameter that we're going to come to it, x plus p is also another parameter, plus q, right? So yeah, this is the standard form. This is the standard form for all hyperbolic functions. Right? This is the standard form. So yeah, the important question to ask ourselves is, okay, what does A mean in hyperbola? What does P mean? And what does Q mean? And how do those affect the graph, right? So as I'll just open a new page now, and then we discuss this. So A is as for quadratic functions. So A tells you about the shape of the graph, and it tells you about the gradient of the graph. So the sign of A will tell you about the shape of the graph. And then the size of A tells you about the gradient of the graph. The higher the value of A, the steeper the gradient, right? Okay. And then P, P, it affects the horizontal shift of the graph, right? The horizontal shift of the graph. And P is also, okay, minus P, x equals to minus P is also a vertical asymptote. It's also a vertical asymptote. So as you will see, so it's the line which the graph cannot touch, right? And then Q, it's it affects the vertical shift of the graph, right? So if you bump a Q by certain units upwards, then the graph is going to move upwards. And then if you bump by few, it's going to go downwards. So yeah, so just to summarize, we'll look into more detail of this in the next page. So to summarize, A affects the shape and the gradient of the graph. P is the vertical asymptote, and it also affects the horizontal shift, right? So if P is increased, then the graph moves more to the left, right? If P is reduced, then the graph moves more to the right. So this is more like analogous to x plus P squared that we had in a quadratic, right? So x plus P in a quadratic that we had. So they're more analogous. So essentially, they talk to the same thing. Okay, so now let's just put this into a table so that we can just, make it a little bit easier for you to just conceptualize what we just talked about, right? So we have 3 parameters, right? Okay, so we have A, then we have P. Okay, actually, let me use different pen so that, we have P, and then we have Q, right? So we said A affect, get the shape, right? And gradient. And the gradient. Okay, so let's talk about the shape first, right? So if A is greater than 0, in other words, if A is positive, your graph, okay, so there are 2 forms or 2 shapes in which your graph for hyperbola can take, right? So either you're going to have a graph that looks like this, right? That looks like this. Or, so essentially, you're going to have a line of asymptotes, right? It's the line of asymptotes. So remember we said what are the line of asymptote? So the vertical line of asymptote, this is always equals to minus P. This is always minus P. And then the horizontal line of asymptote is always equals to Q, right? So like these are broken line asymptotes, remember asymptotes. So like the asymptote where they meet, right? Where they meet, they form 4 parts, right? They form 4 parts. So essentially, how A help us, so if we look at the sign of A and we've already plotted our asymptotes, then A tell us whether our graphs, they're gonna be sitting between the first quadrant, the first, second, third, okay, say fourth, right, fourth. So the graph is either it's going to be between first and the third quadrant, or it's going to be between the second and the fourth, right? So whether it's going to be between first and third or second or fourth, it depends on the sign of A. So if A is positive, your graph is going to be in first and the third quadrant. And then if A is less than 0, in other words, A is negative, your graph is going to be let's use different pen, it's going to be in the second quadrant and the fourth. And bear in mind that this graph, you can never touch what these lines, right? These lines are lines of asymptote. So these are the lines where the function is undefined. You cannot take those values, if that makes sense, right? So you cannot take those values. So, but the important point to note here is that sign of A tells you whether the graph is going to be between first and the third or second and the fourth. So positive first and the second, negative second and the fourth, right? So let's say A greater than 0, it means first and third, right? Okay. Okay, and then A less than 0, it means that second and fourth. Essentially, that's what A means. That's what A helps us to do. Okay, and then from there, the magnitude of A just tells you about the gradient, right? So if A is very high, your graph is going to be very steep. It's going to be very steep. So think of it as you're going to have, if A is smaller, you're going to have a graph that is more wide. Then if A is very high, it's going to be steep like that, if that makes sense. Okay, so yeah, that's all about A. And then now let's look at P. So we already mentioned that P is it's a vertical asymptote. Okay, no, not P, minus P. So x equals to minus P equals to a vertical asymptote, right? Asymptote. Okay, it's a vertical asymptote. And then another thing that we mentioned about P is that if P in that equation, if P is greater than 0, in other words, P is positive, your graph is gonna shift slightly to the left, right? So in other words, your graph is gonna, so let's assume A is positive. Suppose A is greater than 0, right? So which means we know that, let's say P, okay, let's do two scenarios. Let's say P is 0 here, right? P is 0 and A is positive. So let's assume, okay, so you have those lines of asymptote. So you're gonna have your graph here and here, right? So this will be Q, remember? This will be Q. It's not like, Y, it's not x-axis, it's Q. And then this is like, P, which is gonna be 0. In this case, it's gonna be the same as y-axis. Okay, so but then now let's suppose P now increases. Let's suppose the P, let's say P now equals to 1, right? P equals to 1 in this. So now like your graph is going to shift slightly to the left, right? So your graph is going to be, so remember your line of asymptote now is going to change. It's no longer going to be P equals to 0, it's going to be minus 1. So like it's going to be here, like your line of asymptote is going to shift, right? It's going to shift. So when that shifts, so that means then your graph is going to be like this. See, so your graph now is going to shift. It's going to shift. So yeah, essentially when the P gets positive, your graph shifts to the left, and then when your P gets negative, your graph shifts to the right, essentially. And then P, x equals to minus P, that's what? That's the line of asymptote. That's the line of asymptote. A vertical one, right? Okay, and then, so yeah, so we said if, let's just write down, P greater than 0, it means your graph move left, right? Otherwise, right. Yeah, so when I say otherwise right, I mean that, you know, if P is greater than, is less than 0, essentially, if P is less than 0 in this case. Okay, so either P is positive or negative, so, or 0. If it's 0, it means the line of asymptote is at y-axis. Okay, Q affects like a vertical shift. So firstly, we said Q. Okay, y equals to Q. Sorry. Let's see. Yeah, y equals to Q is firstly is the horizontal asymptote, right? So it's a horizontal asymptote. So y equals to Q. That's horizontal. Yeah, horizontal asymptote. And then now let's go back to our graph. So if Q is positive, if Q is greater than 0, right? If Q, okay, let's start where Q is 0, essentially. Let's start with where Q is 0. So if Q is 0, if Q equals to 0, then your graph is gonna just be, okay, so let's suppose, so this is your graph, right? So if this is Q, if Q equals to 0, which means like, you know, like your asymptote is gonna be at the x-axis, right? It's gonna be at the x-axis. So you're, and like, let's assume A is also positive here. So your graph is gonna be like this, right? So let's assume P is 1. I mean, P equals to -1. Let's suppose P equals to -1. So which means the line of asymptote is gonna be here, which is at 1, right? So you're gonna have this guy. So this is y-axis, right? And then you have this line of asymptote here. So then, yeah, your graph is gonna be here, right? This is where your graph is gonna be, because that's where the line of asymptote they meet. Right? The line of asymptotes. The line of asymptotes, right? They meet here, and then they form 4 quadrants, right? Okay, but then now, if let's say now Q increases, so if Q now, if Q is equals to 1, right? If Q equals to 1, so what's going to happen is that this line, the green line, is going to move upward to 1, right? It's going to move here. That's going to be your new asymptote. So then your new intersection between for this line is going to be here. Then your graph is going to, look at your graph. Your graph is going to move upward, right? So I'm going to use let's use this color. So your graph is going to move upward, right? It's going to shift upward. So it's going to shift upward and become here. You see, your graph moves upward, and then this one also moves upward. This one also moves upward. You see, so essentially, yeah, the Q shift your graph up or down. So if Q positive, your graph goes up, and then if Q negative, graph goes down. If Q is 0, your graph is just, you know, at the y-axis, right? Essentially. Okay, yeah, that's all about Q and, you know, A and P. So essentially, if you understand this impact of these 3 parameters, you're already halfway there in terms of answering any exam questions, right? Okay, so let's go back to our, okay, so we look at the standard form of a graph. So standard form, we said this is the standard form, y equals to A over x plus P plus Q. So if there's nothing here, if it's just A over X, it means P equals to 0. And then if there's nothing there, it means Q equals to 0 essentially. And remember what X equals to minus P is vertical line of asymptote. Y equals to Q is the horizontal line of asymptote. Okay. And then we talked about line of asymptotes, right? But yeah, there's another important, okay, I just want to jump the domains and get to, okay, maybe let's talk about domains. You can come back to line of asymmetries, right? So impact of each parameter, we covered that. So So yeah, since our function, okay, so remember from the previous lesson that a domain is a set of all x values that the graph can take without being undefined, right? All the set of x values that the graph can take without being undefined. And then y is all set of y values that the graph can take, essentially. Okay, so if we look into our graph, suppose we have that graph y equals to a over x plus p plus q, right? So if we look into the shape of, suppose a is positive, right? So if a is positive, so which means if we draw this graph, so you're gonna have, okay, this is Cartesian plane, right? So this is y, this is x, right? But remember, we need to draw what? We need to draw the line of asymmetry, right? So let's suppose p is negative, right? So suppose p, suppose p is greater than 0. Okay, it's positive. And then q, suppose is greater than 0, right? So let's suppose all of them are positive. So then what's going to happen is that you're going to have this line here, which is going to be q. This is y equals to q, right? So that's horizontal asymptote. Okay, and then we're going to have, remember, vertical asymptote is equals to line x equals to minus p. It's not x equals to p, it's x equals to minus p. So then if p is positive, then that means x minus p is going to be on the negative side, right? So let's use the green one. So you're going to have this. Okay, that's minus, okay, x equals to minus p, right? Okay, so now you have 4 quadrants, right? So A is positive, so which means our graph is gonna be what? Our graph is gonna be into this quadrant. Remember, can never touch this line, right? It's gonna continue going upward, can never touch that line. This is our graph, right? Okay, so let's look into our graph. So if this is like a graph that we have, so this means that if you look at this graph is going to continue to go to the right all the way. It's going to continue to go to the left, but there's only one point which this graph can never take, right? Or which, like, yeah, the graph can never, it can never touch this line, essentially. It can never touch this asymptote line, right? Asymptote line. So which means that at the domain of this function, so x is going to be element of all real numbers, right? Except that, x cannot equals to what? Cannot equals to minus p, essentially. Can you see? Like, x can take everything, but it cannot take this guy, because if you take this guy, this thing is going to be undefined, right? Because you cannot divide by minus 0. You cannot divide by 0. So if x is equals to minus p, then that guy is going to be 0. So you cannot divide by that. And also, if you look at your y value, right? So if you look at y for range, so this is domain, right? Domain. If you look for range, so this, like, yeah, the graph can take any y value, like, but the problem is just when you get here. So it cannot take this, y value, right? It cannot take this y value. It cannot, because this y value correspond to what? This y value correspond with, sorry, I mean to say, like, yeah, this is an asymptote, horizontal asymptote. So yeah, your graph can take anything, all element of real numbers, but except for this guy. So which means the range is going to be y is element of all real numbers, except that y cannot equals to Q, right? Because the graph is going to be undefined there, right? It's going to be undefined. So essentially, you can see that your domain and the range from this graph will always be element of all real numbers, except that it cannot take asymptotes as what as the values for either y or x. So essentially, you can generalize that at the domain. So if you want to see this, you can plot another graph where a is negative, right? You're going to see that the results are still the same. That's because at the domain will always equals to x element of all real numbers, but x cannot equals to minus p, right? X cannot equals to minus p. And then the range will always be y is element of all real numbers, but y cannot equals to q, essentially. So this is all coming from the graph that we plotted here, right? So asymptotes are the lines that the curve cannot touch. So if the curve cannot touch that line, it means you can't take the y value for that is not going to be defined. Then the x value for that is not going to be defined. It's going to make your graph give error, right? Mathematically. So yeah, essentially, sorry. Go back. Yeah, so this is essentially, the general formula for a domain and the range, and they all come from the graph from the asymptotes if you look into them. Okay, so yeah, and then I think the last part, which is important to understand, is being able to derive, the equations of lines of asymmetry. So remember, the line of asymmetry is the line that sort of divide the curve into two equal parts, right? So if you remember, for let's say a parabola, so we had the line of asymmetry being what? Being x value of intercept, x equals to minus b over 2a. So that line, like, it cuts the graph into two equal pieces, right? So that's the line of asymmetry. So similarly, with the hyperbola, we do have two lines of asymmetry, which they sort of meet at asymptotes, at the way asymptotes they sort of meet. They split your graph into two equal parts. So sometimes in exam, they can ask you to come up with the equation for either, let's say, a line of asymptote that has a positive gradient or line of asymptote that has a negative gradient. So let's look into that. So if we go back to our example of where a is greater than 0, and then you have p greater than 0 and q greater than 0. This is just one specific example, but the principle, is the same, even if p was less than 0 and q was less than 0, and a was less than 0 as well. Okay, so you have a graph that looks like this. Okay, so, and then you have a line Q. This is line Q. It's a dotted line. So yeah, I'm just doing a solid line, but it's a dotted line. So y equals to Q, right? And then this is x-axis, obviously y-axis, right? And then you have line x equals to minus p right here. X equals to minus p. Okay. So, okay. So remember, this is your way of when we talk about the quadrants. So this is what we're talking about. You're talking about this, this 1, 2, 3, 4. We're not talking about, like, the quadrants that are formed by y-axis and x-axis. We're talking about the quadrants that are formed by what? By the line y equals to q and x equals to minus p. They form 4 quadrants, and then the size of A, I mean, the sign of A will tell us whether our graph is going to be in here, or like, other way around. Okay, so what I'm trying to get to here is that there are two lines of asymmetry that, you need to be able to derive the equations for it. So then you have another graph here. So these lines of asymmetry that I'm talking about, so these lines, they meet at this point, right? They meet at this point. So one of them is going to go upward like this. Okay. And then the other one is going to come this way. The other one is going to come this way. The other one is going to come this way. Essentially, right? So these two lines, right? These two lines, they sort of cut your curve into two parts, right? So obviously now because of your graph is sitting between, the first and the third. So this line, the black line, is the only one that is cutting your graph into two equal parts, right? So obviously this thing is not drawn, this part here is not drawn fully to scale. So it looks like it's smaller, but yeah, it's going to go up. So essentially the part that is cut by this line on top and the bottom, they will be the same. And then similarly here, the part that is cut by this graph, on top and below, they will be the same. So this is the one that has a positive slope, right? It's increasing, has a positive gradient. And then this is the one with the negative gradient, right? Remember, whether the gradient is positive or negative, we see it by looking at where, if X values are increasing, or Y values increasing. If that's the case, then it's positive. Otherwise, it's negative. So essentially, if our graph was sitting into this quadrant, right? So if we had the graph here, so let's use this guy. Yeah, so if our graph was in this quadrant and here, then yeah, like this line, the blue one, was gonna cut our graph into two parts, right? But then since our A is positive, the graph is sitting in 1 and 3, then this line is the one that is cutting the graph into two parts. Otherwise, the blue one will do the job, right? Okay. So yeah, the point is, in exam, they can ask you to derive the equation of line of asymmetry. When they say equations of line of asymmetry, they want you to derive the equation for this line and this one. And then, but if they just say like determine the equation for the line that has a positive slope, then you derive the equation for the black line. Otherwise, if they say negative one, you derive the equation for the blue one. So there are two basic forms. Remember, these are straight lines. So equation for straight line is y equals to a mx plus c, right? So the gradient for this line, they are 1. Like all of them, they have a gradient of, okay, they have a gradient of magnitude of 1. The other one is going to be positive 1. The other one is going to be negative 1, right? So essentially, it's because, so this line, they meet, yeah, so these lines are drawn in such a way that, like the gradient here is 45. I mean, the angle is 45. So then if you take like the formula of tan theta equals to m, then you're going to find the gradient for this one is 1. But then since these lines, they are perpendicular to one another, right? So at this angle that they meet, this angle is always perpendicular. It's always 90 degrees. So that means that obviously, if you know the gradient for one line, then you can determine the gradient for another line using what? The product of m1, m2 must give you -1, right? So if you know the gradient for m1 is 1, then which means for m2 is -1. So yeah, I mean, the reason why it's 1 is because of like the angle that this line forms with the x-axis is 45, and then and they always meet at 90 degrees. Okay, so the equations that you can get is either y equals to x Remember, the gradient is 1 for the one that is going upward, plus, let's say C, right? Let's say C1, which is y-intercept that we don't know where the line is cutting the line is cutting the y-axis. And then another equation is going to be y equals to minus x plus C2, right? So this is for the positive one, right? The one with the positive gradient, and this is for the one with negative gradient. Okay. So for us to determine these equations, remember we already have gradient. So for us to determine these equations, we need 1 point, right? We need 1 point that you can substitute here and here and so for C1, and then here and here substitute for C2. So if we look at these lines are meeting at this point, right? And at this point, this is a point where the asymptote they meet one another. This is where the line y equals to q equals it meets with the line x equals to minus p, right? So which means the coordinates at this point, so they have a common point, right? The coordinates for this point here is, the coordinate for that point is minus p and q. So those are the coordinates, right? Those are the coordinates of where those lines they always meet. So those lines they always meet where the asymptotes they meet one another, and then the one going upward has a positive 1 gradient, and the one going downward has a negative 1 gradient. So since you already know the gradients and you have 1 point at which they meet, then what you can do is then to substitute this point into this equation. So for C1, and then substitute this point into this equation, and then solve for C2. And then you will have your equations of lines of asymmetry. Okay. Yeah, I hope, this makes sense. If it doesn't, please give me your questions in the comment section, or yeah, just message me. I can, try to help you with this explanation, because yeah, sometimes these concepts are not quite clear for some of the students. So yeah, but essentially, if you know your asymptotes, and then the gradient, which you always know because it's either 1 or minus 1 depending on whether it's increasing or decreasing, and then you substitute that point, then you can solve for those intercepts. Yeah, the y-intercepts of those line of asymmetries, which are linear functions. Okay. Yeah, the last point that I had there was just around the intercepts. So intercept, as I said, the principle is the same for any function. So for x-intercept, it implies that we need to let f of x equals to 0 to solve for that. And then for y-intercept, we need to let x equals to 0 in the f of x function, right? Because, as we said, where the graph cut x-axis, at this point, where the graph cut x-axis, the y value is 0. That's why we let f of x equals to 0. And then at this point where the graph cut y-axis, the x is 0. That's why we set x equals to 0, essentially. Yeah, that brings us to the end of the concept that I wanted to share with you guys. Yeah, I'm really hoping that this will help you a lot in answering exam questions. So yeah, I'm gonna make a video where I apply this concept to actual exam question, and then so that we can just see how we apply them, and also, yeah, just be confident, right? Because you will have seen how they apply in exam questions, and put them into practice, and then from there is just for you to just attempt as many questions and try to see different set of questions that the examiner can ask you. And then, yeah, I think you'll be ready by the time you write your exam. Okay, thanks for watching this video, guys. Please don't forget to like and subscribe, and yeah, please share with me your comments if you find the content very useful, or if you want to see something else that you're struggling with, please do let me know. And yeah, I'll try my best to help you as much as I can, because I want to see you actually excelling in this upcoming exam. Yeah, I'll see you on the next video. We're going to be looking into, I think, exponentials, and also just doing the actual practice of the exam questions. Okay, cheers.